Hello everybody, I'm Paul Beckwith. Although it may look like I'm in Scotland with all these buildings around me made of stone, I'm in Ottawa at Parliament Hill, and there's a sound and light show going on, so I thought I would show that in the background while I was giving a kind of almost year-end sort of summary of some of the items that I want to talk about that are ongoing in terms of extreme weather events around the globe. But first I'm going to specifically talk about what's happening in British Columbia. So I'm sure you know the phrase by now that we're experiencing weather wilding, weather whiplashing, and weather weirding in our climate casino. And I've talked a lot about the extreme weather events that arise, specifically in British Columbia most recently. So they had enormous a heat dome sitting over large parts of British Columbia back in June, and that set temperature records reaching almost 50 degrees Celsius, actually 49.6 degrees in interior BC in a town called Lytton, and then that town essentially burned down. In the last, then of course there's been loads and loads of wildfires also in British Columbia, and then more recently in October, November, there were 7 atmospheric river events that inundated British Columbia with huge amounts of rainfall and caused massive flooding. And now British Columbia is among the other western provinces that is experiencing record cold weather outbreaks. So often when we talk about weather extremes in the climate casino, it's heat waves or droughts or torrential rains, high humidities, nearing wet bulb temperature, that sort of thing. But on the other side of the coin, climate change disruption can cause a large increase in cold weather events. The cold, what we're seeing, call it the cold dome, as opposed to a heat dome sitting. So what's happened is the jet streams are so weak and distorted and wavy in the north-south direction that at the moment they've allowed the polar vortex normally circling the Arctic to sweep southward, and it's covering large amounts of British Columbia, Alberta, moving into Saskatchewan, and also in Manitoba. So to give you an idea of some of the temperatures that were reached in the Northwest Territories recently, I believe around Christmas Eve, the temperature reached minus 51.1 degrees Celsius, which was the coldest part of Canada by far at that point. And meanwhile, 1,000 or 1,500 kilometers away, Kodiak, Alaska, hit a temperature of 18.6 degrees Celsius. So Kodiak, Alaska was under a ridge of the jet stream, which brought very, very hot air up to much higher latitudes than it should have normally been. And the troughs of that same wave of the jet stream brought extremely cold Arctic air, basically Siberian air masses, southwards, much further south than it would normally happen. I've mentioned this for quite a while, that normally, when we think about temperatures, we think that as we go further and further north towards the poles, it should get colder and colder. Well, that's the whole thing that is messed up, with the jet streams. That would occur if the jet streams were mostly zonal or moving from west to east. But now, because of the huge warming of the Arctic, 4 to 5 times warmer than the rest of the planet, the jet streams are very wavy, and we no longer can rely on decreasing temperatures as we increase latitude. It just depends on your position, where you are on the Earth relative to this wavy jet stream, relative to the ridges and troughs, which are often getting stuck in place, giving us persistent extreme weather. So the cold temperatures we just reached in parts of Alberta, I guess it was Grand Prairie, Alberta, reached a temperature just a few days ago of minus 44.4 degrees Celsius with a wind chill of minus 56 degrees Celsius. And those temperatures were 15 to 20 degrees Celsius colder than the temperatures in the Arctic at the North Pole. So basically what has happened is the cold Arctic air has spilled out of the Arctic and come far south over parts of Canada, Western Canada and the US, and that air has been displaced, of course. That cold Arctic air has been displaced in the Arctic with warmer air. So it's a double whammy, right? When we talk about Arctic warming, normally it's the warming that's happening from increased sunlight absorption in the solar, in months when the sun is shining, in the summer months, in the boreal summer in the Arctic. But what's happening now is, because the jet stream is so distorted, that cold air, very, very dense air, is just sliding its way south, pushing aside all the warm air, or actually getting underneath it because it's much denser, forcing the warm, humid air up, and that caused the tornado swarm that we saw recently that swept across Kentucky and many other states in the US. So this climate system is, of course, all connected, right? The extreme weather events are all connected. And it's actually quite disturbing that, I just read 5 or 6 articles as I was walking from my house down to Parliament Hill. I knew the light show was on, and I wanted to record my video there. So you don't just have to look at my face, you can look at all of the, the light and laser display, which is actually quite impressive. So I read 5 or 6 articles, CTV, CBC, the major news stations in Canada. Not one of them attributed any part of this cold air outbreak to climate change. Not one of them. I mean, it's actually totally absurd when you think about it. So this is why I have to continue to put out videos, tying extreme weather events that we're experiencing in real time with climate change. Now, occasionally you'll see the camera jiggle a bit, and what I'm actually doing is I'm just holding it in my hand, and I'll just I just have to switch hands because it's actually, my fingers are getting a bit chilly, and people say I can hold the camera fairly still for long periods of time, but it's cold and windy right now on the hill, and you can see some snow. We're having a much milder winter than we would normally have. The cold air break, the cold air outbreak from the Arctic has gone down to the west of Canada and the US. On the east of Canada and US, we're basically so you're under a trough in that whole region, which is the jet stream is in a trough, so all the cold Arctic air, polar air, has been able to spill down as far as the jet stream boundary, which is running quite far south. But then the wave of the jet stream is heading north about mid-Canada, US, and the eastern part of Canada and the US are in very, very hot, much hotter than normal. We're having extremely mild winter here in Ottawa. There's heat record temperatures have been set in places right now. I believe Corpus Christi area of Texas was reaching like 38.8 degrees Celsius, something like that. Some of the areas in BC, they're just not used to the cold temperatures there. I mean, they're used to very cold temperatures in Alberta and, Calgary, Edmonton in Alberta, and Winnipeg in Manitoba, for example. They're used to snow and very, very cold temperatures, but the temperatures that, in Edmonton, for example, that have been, minus 41.6 in downtown Edmonton, and I said minus 44.4 in Grand Prairie, outside of a city in Alberta, outside of the main cities. Those temperatures are, we reach temperatures of minus 10 to minus 30 in the winter in those regions, but not the minus 40, mid minus 40s. I mean, that's way cold. So actually ski resorts in Alberta have been closed down because your skin exposed to those temperatures with any type of wind, it freezes in minutes. So moving on to British Columbia, the temperatures in Vancouver have been minus 14.4 degrees Celsius a few days ago, with a wind chill of minus 23 Celsius. And this was for many, many days. So the problem is they're just not used to cold temperatures in a moderate coastal city like that. So the problem is the infrastructure fails, right? People's pipes running to houses and businesses under roads freeze solid and burst and release water fountains and cause huge amounts of damage because the entire road or place has to be dug up in order to access the broken pipe. Victoria reached minus 8.7 degrees Celsius a couple days ago. And that was the lowest recorded temperature in Victoria since 1874. So we've been seeing heat records being broken and cold records being broken, and British Columbia right now seems to be in the crosshairs of climate disruption, in the crosshairs of the climate casino with all of these cold air outbreaks. So meanwhile, on the other pole of the planet, we're having rumblings in Thwaites Glacier. So there was a great Rolling Stone article, which I just read when I was coming over, by Jeff Goodall, and he was on a research ship in 2019 just off the Thwaites Glacier in next to the ice shelves extending far out from the land. These ice shelves can be easily 100, over 100 meters high. And it was in a clear ocean one day. The next day, they were surrounded by icebergs the size of aircraft carriers. What had happened was a section 21 miles long by, don't remember how deep it was, 14 miles or something like that. It broke up, it broke off, it calved, creating all of these massive icebergs, which then floated away from the ice shelf and surrounded their ship. So things can happen extremely quickly. And of course, the American Geophysical Union met just a few weeks ago. And it was too close to the COP26, or I would have considered attending, but I did watch a number of the online events, and one of the Arctic report card came out, and many papers on the Arctic and Antarctic, and mostly this conference has turned into climate science papers. But there was a big major study done of the Thwaites Glacier, and this glacier is the size of Florida, and it's destabilized. It's sort of it can have a possible collapse, the paper was arguing, and it explained many reasons as to why within about 5 years or so, 5 to 10 years. Now, if that goes, that would be basically never seen before in recorded modern history. It would be a totally new ball game. It would cause an abrupt rise of sea level as all that calved ice eventually melted out. It would also be uncorking like uncorking a bottle, you know, allowing a great increase in the other glaciers inland to increase their flow rates towards the coasts and towards the oceans, where they could cause a big rise in sea level. The West Antarctic ice shelf in Antarctica, as you know, is grounded a lot on bedrock that is kilometers below sea level, many kilometers below sea level. So as the sea level rises and as we get more melting of these glaciers, they become floating in places where before they were anchored to bedrock. And with wave action and increased sea level rise, you know, which is rising for a number of factors, water expansion with increased temperature, increased alpine glacier melt, increased Greenland glacier melt, and of course the Antarctica melt, which is mostly melt from below by the rapidly warming water. Then all of these factors that raise sea level will make these glaciers more unstable and lead to a cascading effect of sea level rise. So none of these things is a surprise to me. I'll refer you to a video, you know, 2 or 3 videos where I talked about can sea level rise 7 meters by 2070, and I gave the argument that that is very possible, that these glaciers can start collapsing very, very quickly. It's not going to take centuries to melt out these massive glaciers on Greenland and Antarctica. There's mechanisms that can occur. For example, I mentioned in some previous videos that the atmospheric rivers are moving, heading northwards. So that's been a California phenomena for a number of years. Think of the Pineapple Express. 7 of them, or 11 of them, just went into British Columbia over the space of several weeks. And if those actually, you know, as we get more and more warming, that phenomena can easily head northward and go right into the Arctic. And if it goes into the Arctic over Greenland, then that would and became a repeated event in that region. That's a mechanism that would, if that was to occur, that would take out large chunks of Greenland ice in a very, very short period of time. I mean, these ideas that it'll take hundreds of years for, say, that glacier to go out, you know, forget those ideas. And how much sea level are we talking about? Greenland is about 7 meters of sea level rise if we lose the ice on Greenland. West Antarctic ice sheet is 4 or 5 meters. And if you include East Antarctic ice sheet, it adds up to a total of 70 odd meters, 70 to 80 meters of sea level rise. So we're talking about irreversible changes on human lifespans. There's some interesting light activity here, so I'm just gonna, I don't know what's going on. I'm just gonna scan around once again so you get an idea where I am. And I'm gonna have to switch hands again with the phone because you know, it's a little bit chilly here and I can't really yeah, hang on. I've got a warm coffee which I'm counterbalancing in the other hand. Okay, so I'll let you enjoy the light show, and you know, as I think of things to tell you, I'll continue talking, but I can take a breath and a couple swigs of coffee in the meantime. I think I mentioned to you a few months ago or a month or so ago, about the World Championship match, which went from late November to sort of mid-December, World Championship chess match, and Magnus Carlsen retained his World Championship title by badly defeating Jan Nepo for short. His last name is Nepo and very long. I have trouble pronouncing it. Anyway, so that's for classical chess, long time controls. They played a game a day. It was, what was it, 7.5 to 4.5, something like that. First person to reach 7 won. And in the last, this week basically, the last number of days, they've had the World Rapid Tournament Chess. So this is a faster time control for chess. It's 15 minutes at 10 seconds per move. And a 17-year-old youngster from India, I believe, won that. Today and tomorrow it finishes, but the World Blitz Championship is going on right now. They play 21 games, and the person with the most points wins. And that time control is, you get 3 minutes at the start of the game. Every move you make, it adds 2 seconds per move. So when you run out of time, you lose the game. So that's a very, very fast time control, which is actually quite enjoyable to watch these grandmasters, these top world players, hanging their queens and, making big blunders. But the caliber of the chess is quite good, and the commentating, it's like you have commentators talking about it, giving sort of a play-by-play, like, any other sporting event. So it's very enjoyable, but I find that it really improves my chess a lot. So the online chess tournaments that I've played since I, studied the games in the World Championship matches at all different time controls, the classical, the rapid, and the blitz, have allowed my performance rating in many tournaments that I've played in the last few weeks to be over 2,500, which is, I'm surprised myself, actually. That's mostly at 5-0 time controls, where you have 5 minutes for the whole game, no time added per move, and if you lose on time, you lose the game. So if you haven't already seen the comedy, Don't Look Up, definitely check it out. There was an interesting article by Peter Kalmus, a climate scientist, on how climate scientists love the movie, right? Because that's what a lot of us face on a day-to-day basis, is the denial and the stupidity of people in power to not recognize the severe threats that we face from abruptly changing climate, the extreme weather events, and we're just heading, very rapidly, we're heading to a place where it'll become more and more difficult to grow enough food to meet the demands of the global population. So this is where we're heading, and I'll do lots of videos on this type of thing. So I'm just enjoying the show there myself. I'll just leave it on. Please remember to check out my website, paulbeckwith.net, and please consider supporting my videos, my research and analysis, and commentary and videos as I try to join the dots on abrupt climate system change. You could, there's a PayPal button on my website, paulbeckwith.net, or you can set up an individual donation or set up a monthly thing. You can also, if you prefer Patreon, I have a Patreon page. You can just go on Patreon and search for my name, Paul Beckwith, and that's another way of doing it. I want to thank everybody that helped me, that supported me to help me go to the COP26 conference, and donations throughout the year to help me do this work, because the donations is my only source of income, and it allows me to continue doing these videos, and I will be doing it for a long time. No plans to stop, and I've been doing them for quite a while now, and there's loads and loads of topics for me to discuss in the next little while. So I'm not going to run out of topics for sure. And I'm also doing work once a week with the Climate Emergency Forum. We film videos, and those are loaded up onto the Climate Emergency Forum website. And I also do some work for Facing Future, and was in a number of presentations for that, for them at the COP26 climate conference. And the work, of course, in climate change is never ending. And, I still argue that it's very important to do this work without having the results in mind. Because, what can one person do to face the juggernaut of abrupt climate change that is hitting us now? Well, one person can try, their hardest to do things using their skill sets, without expecting any result or any change. And if enough people think like that and act like that, then maybe we can affect change. And, we need to consider we need to deploy like a three-legged bar stool approach. We need to slash fossil fuels to zero. Subsidies for fossil fuels are obscenely high and increasing, and those need to be slashed. We need to pull carbon out of the atmosphere, CO2 and methane, and we need to deploy solar radiation management technologies, develop and deploy them to cool the planet, to buy enough time for us to lower the CO2 levels in the atmosphere, to restore a healthy climate, to try to bring back the climate to what the chemistry of the atmosphere and oceans and the climate to what our grandparents and their grandparents enjoyed. Okay, well, thank you very much for listening, and I wish everybody a happy new year. I'll probably pop up a couple more videos before the new year, but in case I don't, I just want to thank everybody for listening, and please consider sharing my videos that's one of the things I need to work on, to try to get more viewers, to try to get more traction with the messages that I have on the science of abrupt climate change, abrupt climate system change. Thanks again, and bye for now.